Today we are talking about three types of Newton's law. Three types of Newton's law, like laws of motion, like fundamentals that describe the forces that acting upon it. The first law states that this stays. An object is motion stays in a motion constant velocity. The Newton's first law is an object it will not change state of motion unless it's acted upon by a net is a motion by inertia. See, we have the motion, we have the push cart. Unless we have to move the table here, like a push there, because that acted is upon a net, like known like inertia. It's like an object. An object has acceleration like F is equals to ma. The third law states the F is equals to ma. In every action, opposite like reactions. There's a thermos. If you put the thermos like this, it's an object with a thermos like that. Of course, you have the point that these things, we have to so heavy like at the table. If you heavy the table like this, it's an object will not change the state of motion. Laws of motion like this. If you push the cart like that, if you have the glossary, is to our walk away. I think just talk about the inertia. Inertia is object in resistance to any change in state of motion. Like that, in the state of motion, the greater is the mass of object, the greater is the inertia. Alright, let's talk about like balance force versus balance forces. Of course, the equal the opposites is the balance, but as imbalance is not an equal opposite. For example, if the car braking like this, if you switch the foot, because the brake is that brake pad is our stop. Of course, like motor like this, let's see how to main motor. If you stop like this, when we move forward like that, like the passenger. If the tricycle like this, if the brake is R, you move around the tricycle. For example, like there is if there is the acceleration like this, will be forward like this, like down, onward into the tricycle. And just like that, when the vehicle stops, onward like this, we will move around the down. If the move forward like acceleration like this, you see the move around like a balance. You know what happens? If you move around, you turn around like right side, like this one, like a motorcycle, like a vehicle. And then the left side, when you move around the turn around, like a motorcycle will turn, like a balance. You know what happens if you're spinning like a hanger? When you're spinning hanger, like you spin like a coat. A hanger tennis ball, like a badminton. Like that. I was playing before like a 2015, like a grade 2, because like I'm playing this badminton before because I am bouncing like that. So that badminton like this will play like management like that. Basically, this is the inertia like badminton like balls initially because they're in inertia. Because the ball like this, like a badminton or like tennis, when you move around like this, if you smash like that a ball, will you spin like this. And the next one is Newton's second law. Newton's second law is like an acceleration an object directly proportional net force. Of course, inversely, being proportional is like a mass. For example, if you push the car like, or the vehicle like that, when you push like this, I've seen that before like pushing car when you not start a battery. Of course, when you not start engine, we push back to start. In the equation like this, the law is expressed by the formula. Like equation is F is equals to ma is 1, 2, and 5. In F is a net force, m is a mass, and a is acceleration. Like this one, if you have a acceleration like that, like equation is the F, m, and a. If the force and acceleration like that, the greater than net force applied is to an object and have a greater acceleration will be. And the mass and the acceleration if you, for the given force, like this one, an object that will force will mass have less is an object with less a mass. Of course, the mass and acceleration like this, if you're given a force like this one, like a harder, like a push loaded. If you push loaded like this, if you want to see that like a push in your car in the vehicles, but I have seen before like a car is like a vehicle. You see that the vehicle like a Toyota Revo, when it's not started, when you push this one, will be start an engine. And if force is a sum of force, like this one is like acting on object, if the net force is a zero, like meaning in either that remain at rest or continue to move constant velocity. In a vector quantity, like both force, acceleration are vector, the acceleration is always be the same directions, like same net as force. And the momentum is, the loss can also be is the expressed in terms of a momentum, which is the mass in the times of velocity. If the state rate of change, like a momentum, equal to net force acting on it. The next one is the Newton's third law. The Newton's third law is a statement when the one object exerts the second object exerts a force that equal in a magnitude and opposite. Like this one, like iteration like a first object. For example, if the Newton's third law like this, if you want to push like this, because an object exerts like a second motion. For example, if the Newton's third law like this, if you have the push the box like that, if you push the box like that, it's all around here to move. Like here, it's like to move around here. And you push like this, if you want around too heavy. If heavy like this, we push back, like that. If you push like this, like around, and move around, and you move back. Unless, if you move like this one, it's so heavy like that. Unless, before like that, you need to push, because you broke a muscles. The key aspects like action is reaction forces, like an occur in the pairs one force is the action, and there is that other reaction. In other reaction like that, when you push it like this one, when you push back like this one, when you fall down like this. In an equal magnitude like an earthquake, it's like a magnitude. But this one is the opposite. It's like a strength is action force is identical to the strength. If you have exercise like that, you have the push like this. When I stand before like a jump like that, for example, here, let me jump for you. But if you know what happened, if you're jumping around like that, of course you have the ground is jumping to the ground. Of course, if you push them like this, when you see the reaction into the jump, you know what happened. If you third law of motion, like a rocket launcher, like this one, the onwards, the action expel half of gas onward like that. If you rocket like this, you have to go up like the rocket. As a swimming, like a swimming pool, if you have to swim like this, you have to swim like that. Unless the water pushes back, like this one, like a swimming. If you have backward the action, is the action like this, the water pushes back. The swimming forward is like a reaction. And that's the end of the third laws of Newton's. The third laws of Newton's, like an object like it will move around. And that's the end of the video. Thank you so much for watching, and see you guys next time.